Today we are going to talk databases, specifically relational databases. After today's lesson, you will have an understanding of what a relational database is, how it is organized, and why Cinderella is so keen on having one in her kingdom. So a relational database is simply a container. Like a toy box is a container for toys, and jars may be containers for mouthwater and candy. A database is a container for data. Oftentimes, a database will be depicted like the gray cylinder seen here, but we prefer a pink one with a smile. Most larger organizations, like companies, universities, or the government, will have a database and will store all sorts of data inside of it. The data the database holds can be any kind of information that an organization might find helpful. The data could be name, date of birth, courses taken, and grades of students that go to a university. Or it could be the names, contact information, and salary information of employees at a company. It could be the contact information of customers that shop at a store and what they buy. We'll see a ton of examples of data throughout this course, so the concept of data will become clearer and clearer as we go on. So in the last slide, we showed all of the data floating into the database without any order. But within the larger structure of a database, there are smaller structures called tables. Most relational databases will have more than one table, and some will have thousands. Tables are the structures that hold the individual pieces of data. Let's take a closer look at the table structure. The table will have a name that describes the general type of data it will store. It will have columns with names that describe the individual pieces of data. We will often depict the table like this, with the table name at the top and the column names below. If we wanted to show the actual data in the table, we could display it a little differently. We could put the table name that describes the data on top. Then we would put the column names that describe the individual pieces of data below the table name. Below the columns will be the rows of actual data. All of this still might be a little hazy, so let's take a look at an example. Let's pretend we have a candy store called Yay Sugar. Yay Sugar has a database to store all sorts of helpful information. Within the Yay Sugar database, there are multiple tables. We'll just take a look at a few of them for now. There's a table called Customers. It stores information about Yay Sugar's customers, like their name, address, birthday, and favorite candy. Yay Sugar's owner wants to store this information because he likes to send its customers a coupon and a piece of candy on their birthday. There's also a table called Sales. Yay Sugar's accountant and owner use the data in this table all of the time. The accountant does it to report their earnings, and the owner does it to see how they're doing and think of ways to improve. The last table we are going to look at is the inventory table. This table stores information about the candy in the store and how much of it is left. This helps Yay Sugar's owner know if any candy needs to be reordered or if they are overstocked on a certain candy and can put it on sale. Let's take a closer look at the inventory table. Within the table are two columns. There is one column that will hold the name of the candy. The other column will store the amount or count of the candy currently in the store. In this representation, we aren't showing any of the actual data, just the table diagram. Here we are showing the table and some of the data that is stored in it. At the top we have our table name. Below are our two column names that describe the individual pieces of data they contain, and below each column is a row holding the actual pieces of data. So we have a row for a candy with the name jelly beans and the count of jelly beans. We can see Yay Sugar has 100,000 jelly beans in the store. Below that we have a row for candy with the name licorice, and we can see that there are 1,000 pieces of licorice in the store. Lastly, we have the third row for lollipops. Looks like Yay Sugar is really low on lollipops and may want to restock their inventory. We are only showing 3 rows of data in the inventory table, but Yay Sugar may have thousands of different candies in the store and thousands of rows of data. Now that you are seeing what a database is and how the data is stored within it, you may still be scratching your head and wondering why Cinderella wants one. Well, let me tell you about the first time Cinderella and I met face to face. During our first meeting, I asked why Cinderella thought she would benefit from a database and what kind of data she wanted to store. She snapped her fingers and a multitude of servants shuffled in, all carrying golden crates. Inside each crate were piles of note cards covered in writing. Cinderella gestured to one of her servants and he jumped out his crate. The ground was littered with notes that contained all sorts of information about Cinderella's subjects. On the screen are what some of the notes look like. Take a moment and look at the types of data the notes contained. What type of information is the data describing? Do you see any information that is similar on the various pieces of paper? Now that you had a chance to see what kind of data the notes contained, we are going to create a table for the information. We will take a look at a single note and see if we can turn this table template into an actual table filled with data. Let's just take one card and cut up the individual pieces of data being stored on the card. First, we have Xavier Interessante. That sounds like a subject's name. 15 Prince Charming Drive sounds like an address, right? Male sounds like a gender. When he drives a carriage off the lot, it increases in value sounds like a description of the subject, or better yet, a tagline. So now that we saw the data and identified the individual pieces of data on a note card, we are going to create a table for the information using this table template. The first step is to come up with a table name that describes the data. Since it looks like the notes contained personal information about Cinderella's subjects, we could name the table Subjects. The next step will be to come up with the column names to describe the individual pieces they store, and then put the pieces of actual data below the column names. Below we have the cut-up note card from the previous slide. The first piece of data we identified was the subject's name, so we will create a column with the name, and put our individual piece of data below, Xavier Interessante. The next piece of data we identified was the subject's address, so we will name that column Address. And we will put the individual piece of data below. Next, we identified a piece of data called that stored the gender, so we will name the column Gender and put Male below. Lastly, we identified the subject's tagline, so we'll have a column named Tagline, and below it will be the individual piece of actual data. So if we cut up the other note cards and put them into the table, we have just created a table that we could put in Cinderella's database. Here is what the table would look like with additional rows of data we took from the cards. So we have Xavier Interessante, his address, his gender, and his tagline. And now we also have Wendy May Prince Will Come, her address, and her tagline. And then a third row of data with Philip Villagidiate, who lives on 1200 Fairy Godmother Lane, who's a male, and has an intellect rivaled only by Cinderella's hairbrush. Lastly, if we wanted to show the structure of the subjects table without the rows of data, we could depict it like this, with the table name at the top and the column names below. We'll use this throughout the course to represent tables. We'll refer to it as a table diagram. So now we see what a table filled with data may look like inside Cinderella's database. So now that you have an understanding of what a relational database is, how it is organized, and why Cinderella is so keen on having one in her kingdom, it's your turn. Open up the Lesson 1 activity and you'll get a chance to create another table for Cinderella's database. And then come on back for Lesson 2, where we'll learn all about Fairy SQL.